time, you know, finding the recordings. I'm going to post them every week on there, and it's always going to be in 2 parts because it seems like it struggles if it's super long. And then you can access it this way. If you, from my computer, it looks like the recording went just fine. If you're having any difficulties, please do let me know and we'll look at it together. So I want to point out a few more things on our Course Connect page. So as I said, lectures for last week are right here. Here we are this week. Again, this is my version. You're not going to see, you see this professor went crazy on putting in all these labs. We are going to be covering the second lecture today. We already did the quiz. This is where you can submit your lab 1 that'll be due by next week's class. And this is the description for the lab 1 and the code book. So about, I'm thinking right around 4 o'clock, we're going to go over the lab. So we'll lecture for the first part of the class. We'll take a break close to like the probably 3:40 or 3:45 or so. Take a break for 10 minutes and then come back in and we'll work on the lab. It's quite short, but it does require that you guys have access to either Excel or Numbers. That's what we'll be using for this class. So since we're going to be doing that after the break, if somehow you need to get a hold of that, that software, let me know. Please do reach out. There's other ways to access the material and to do the same analysis. So don't freak out if you don't have it. We'll make it work. Okay.
Yeah. I have a question. Did you ever find out if we could use Google Sheets for those or no?
So I could not figure out if Google Sheets would do like a pivot table that we need to do today. Within Google Sheets, you can do some of the like means, you can do a standard deviation, all of those, yes, they will work, but producing tables and graphs, it doesn't seem like it's capable of doing that.
Okay, perfect, thanks.
Yeah. So that'll be helpful. Google Sheets will be helpful later on this semester. For this first one where we're doing a pivot table might be a little bit more challenging. Okay, so that's on the docket for today. So let us get started. I will do this real quick and then I will, where are we in the world? Okay, let's do that. Okay. Can you guys see my screen?
Yep.
Okay, super duper. Oh, what's going on? Okay. Can we see the big screen? And it'll move. Are you guys seeing the slides changing?
Yep.
Okay, just want to make sure because I know the first week that was a problem. Okay, so today what we're going to do is how to organize data. That's a huge piece of what we do in statistics is we get numbers and then we need to figure out what the heck does it mean and how can we present the information in a way that'll make sense. And actually I brought this here. I'm so lazy, it's all right off next to me. Okay, this is something I got in the mail just last week. Okay, I'm going to show it to you. This is a report on my voter behavior. It doesn't say anything about my voting affiliation or anything like that, but I don't know if you guys can see what it says. It says, how do you compare with others, right? And then it has 2 bar graphs. It says your participation and average of all voters. And if you look at the bottom, it's telling me my participation is what?
Awesome.
Yeah, it's above average. My voting score is above average. Okay, so when they create a graph like that, what are they communicating? Like what information do you see on this? Anyone? Like what are they showing?
The average of how many votes you have put in towards the average of how many other people's votes they put in.
Okay, that's one very good hypothesis. Yeah. Other hypotheses.
Voting consistency?
Voting what?
Consistency?
Voting consistency. Okay. Anything else? What else can you guys think of? the main point I want to take home here is how much data is given on this graph.
Very little.
Not enough.
Very little. There is hardly any data on this graph. In fact, really the focus is that last line, which is that my voting is above average, which as a voter, I was like, heck yeah, it's above average. Turns out, you know, I just became a US citizen 4 years ago, and I was like, I'm gonna make, not 4 years ago, that's not true. 8 years ago, I'm like, I'm gonna make it count, make my vote count. But there is no label for any of the axes, right? There is no numbers, right? Is this actually, because this looks like a pretty significant difference. This bar graph, my participation is much higher than this one. Is that by 1? Is that by 100? What is it by? There's hardly any data. This is something you will see used in advertising, used in popular media quite often. It's a graphical depiction of statistics or some sort of numerical representation that lacks context, that lacks any sort of comparative value for you to have a sense as to whether it means anything, right? But we are fed that all the time. In what way are we fed that? When do you guys see bar graphs like that? We see them all the time. Just think, what do you see? Where do you see data depicted?
I feel like a lot of like cell phone ads have like has the best like cellular reach, and they always have like a little different bar graphs in their commercials.
So you're cutting in and out a little bit here, Grace, but I think what you were saying with cell phone companies, is that what you were saying? And how the coverage maybe that they have?
Yeah.
Okay, yeah, totally. We see that, definitely. Cell phone companies, like, this is your company and how, you know, the coverage we provide here at insert whatever company, Verizon, and here are all the others, and it'll be much smaller graphs. But again, there's no values, there's no like, what was it that was measured, which seems like it would kind of be important, right? Anything else that you guys see?
Detergent,
Detergent, okay, say more about that.
like who prefers it over who, like what's better, like what makes it better.
Totally. In fact, insert any product and in their claims of how good they are and why you should be purchasing them, they'll provide like, well, most, again, whatever their target consumer is, most moms, most teenage boys prefer the smell of whatever latest deodorant is, right? So, and they'll put some sort of graph, or you might see a pie chart, right? And it'll have a huge carved out section for like, this is us, right? Way better than the rest. So again, we use graphs and tables and pie charts, all of those things, which we'll talk about today, to better and more easily explain away data. But if we are not doing it correctly, meaning with labels, meaning with some sort of code book or a legend that explains what it is you're describing, it is meaningless because people will insert whatever they think. And that's where data can really be manipulated, which can be real problematic. Okay. So what are the goals for today's class? We're going to be talking about how to construct and also analyze frequency, percentages, and cumulative distributions. We'll talk about, again, what are proportions and percentages within groups. We're going to look at how to compare frequency and percentages distributions for nominal, ordinal, and interval ratio variables, which we talked about last week. And we're going to learn also how to construct and interpret charts and graphs. Now, full disclosure, today is a really long lecture. I'm not sure we will get through all of this. We'll do the best that we can, and whatever we don't have a chance to, we'll start with that next week. As always, if you have any questions, comments, confusions, something is glitchy, just speak up as much as you can, because I've minimized all our faces. So if you're like this going, yee, and I don't have the chat alert either, so I'm not gonna be able to see that. So just use your voice to let me know. That'll be the simplest way.
Sounds good.
Oh, all right, so what is a frequency distribution and why do we care about that? A frequency distribution is a list, table, or graph that reports the number of observations or the number of times we counted a specific things that we're measuring. and it categorizes it into variables. So very first day of class, I divided the class between male and female as we counted shoes. That would be a frequency table, looking at gender and the number of shoes one owns. That was a very basic frequency table, but that's an example of one. It is, in fact, the most basic way to organize data because you're not manipulating it, you're not doing any statistics to it, you're just organizing it and clumping it. And in fact, if you think about how we interact with children, that's often one of the first ways that we teach them on how things are the same and things are different, is how do we come up with groups and then sort, right? It's a simple organization tool. So here's an example of that. This is the frequency distribution for categories of region of birth for foreign-born populations in 2012. It's a mouthful. So this is according to the US Census, and it states there's 13% of the US population that were born outside of the United States. And this is giving a frequency as to those countries. So it starts with Mexico. Again, these categories can be maybe a bit problematic because it says region of birth, but then there's a country. Country is not really a region, but anyway, this is the example in your textbooks. I'll try not to be so critical. But almost 11.5 million come from Mexico. Second is South and East Asia, then Caribbean, Central America, South America, Middle East, and then all other, for a total of 40.7 million people. So again, you can create a frequency table, which means when you were gathering your data, this is specifically with the US Census, people asked, you know, how many people live in this household, income, the basic questions of the US Census, and they'll ask, where were you born, right? And then you'll have to pick a category as to where you were born. They then gathered all this information and then tabulated it and organized it into groups, and that's the frequency they received for each of those groups. Basics of a frequency table, or frequency distribution, I should say. Oh, did it just freeze? Looks like it did. Okay. You guys seeing all this, or did it totally freeze? We should be at proportions.
I see proportions.
Okay, perfect. A proportion is the relative frequency obtained by dividing the actual frequency, the number of time it occurred, by the total number of cases. So proportion is denoted by P, and it is the dividend or the quotient of the frequency divided by the sample size. So again, when we're looking at particular, proportion, you're wanting to know how significant of a group is that section, right? How much of it is that? So for Mexico, for instance, it'd be taking 11,489,387 divided by this total, which is 40,738,224. And so then I know the proportion of those who are born in Mexico. Now, oftentimes proportions segue quite easily into percentages, which is taking your proportion times 100, right? So again, does it matter to me that the proportion of Mexico is something like, whatever those numbers were, we can look again. That's like a little less than a third, like 0.27. That's less meaningful than if I said 27% of those who are non-US born immigrants came from Mexico. That it's a simpler way to describe the data at that point. So again, it's a percentage then is the relative frequency that's obtained by dividing the frequency in each category by the total number of cases and then multiplying it by 100. So let's look at a slightly different example. So this is the frequency distribution of variable number of children. So this is the number of children per household and the frequency of it within a specific sample. So this is a sample of 40 families, and they asked them, how many kiddos do you have in your family? And as you can see, 13 of them had no children, 9 families had 1, 6 had 2, 8 had 3, and then you can see it's ones all the way down the bottom for families of 4 all the way to 7 or more. Was there a question? No.
What did you say GSS subsample meant again?
What's that?
What did you, so I'm looking at table 2.6.
Yep.
numbers of children, GSS?
Oh, that's the general social survey. It's just a survey that's passed out. So earlier we were dealing with the US Census so that you guys know where I'm getting these numbers from. In your textbook, they have a lot of these examples. So that's the general social survey. And that's taking a subsample of that survey and it provided this data.
Okay, thank you.
No problem. So again, I can say, 13 out of 40 families had no children, but it's a little bit more meaningful, especially when you're communicating data, to say 32.5% of families had no children. Does that kind of make sense, the way to, again, communicate that? Hopefully that's adding up.
Works for me.
All right. So then how do we go about creating a frequency distribution when we're looking at nominals or nominal variables or categories? Because then again, we're not going to have some sort of dividing number, right? It's going to be by category. So if I am looking at a class and I want to know in statistics at Aquinas, are students enrolled in my class mostly male or female? I could go through and assess, and then the way you would do that is you would write a tally. I'm sure, again, you guys have done that before when you're counting, or think of a store doing inventory, you do tallies. Now, this example drives me a little bananas because do we write tallies this way? I don't know about you, I don't. How do you guys do tallies?
The 4 and then the cross. for the
Yes,
5.
exactly. Yeah, this is nonsensical to me. That's not very easy grouping. The reason why we do 4 and a cross is that that clump I know is 5 and I can count by 5s, which is much simpler. So somehow the textbook, anyway, drives me a little batty that they did that. So here, if they had like 3 clumps of 5, it would show much more easily that it's a frequency of 15. And females, same thing, 5 groups of 5, frequency of 25. And then you can see the percentages. Okay, so very typical frequency distribution, frequency table to highlight some data. Similarly with ordinal variables, you can do the exact same thing, have tallies, frequency, and percentages. You just need to make sure that when you're writing them out, like male and female, whether you write male first or female first, it doesn't really matter, right? But with ordinal data, you want to go in ascending order. So you want to make sure that it makes sense. You're not going to randomly write, like you wouldn't have very dissatisfied, very satisfied, neutral, satisfied, dissatisfied. You know, that doesn't make any sense. So you want to keep them in order of how they were presented as the options. So this shows here levels of happiness: very happy, pretty happy, not too happy. And you can see again the frequency, 9, 25, and 6 out of a total N of 40. And then here you can put the percentages as well. So that again, when you're communicating, if you think about it, as we add columns through it, like tallies, that's the hardest way to really communicate data, right? Just the tally, that's hard to see. You have to kind of count them one by one to get to your answer. The next level then is frequency. Well, seeing 9, 25, and 6, that's helpful, but when it's not in the context of a proportion or seeing what it's like out of the total number of students, it's a little less meaningful. So that's why then the next column, looking at percentages, that gives you the most valuable data when you're trying to represent that. Okay. So making a frequency table, if you're looking at a student's social interactions over a week. So this would be gathering data from individuals, right? So I think I have it in the other table right here. Is there a total number? So 94 college students. So I asked 94 college students to give me their number of social interactions over the period of a week. You can see the data at first. This is actually in order, right? From 0 all the way to 48. And you can see the tally marks for each. Well, then I need to organize that again because this is kind of messy, right? I don't need to have the 48 categories just displayed this way. So the next way to display it would be to have it neatly into a table, right? And then highlighting, again, a score, like having 0 interaction over a week, the frequency is 0, 1 is 2, and so on and so forth. But how easy is it to walk away from any meaningful information looking just at that table? What do you guys think? Looking at this table, you're like, oh yeah, this, I can see clearly the pattern here.
I can see that 0 is a frequent number.
Okay.
Also, I think Ashley's audio is a little weird, but it's good for us. That's
Oh.
happening in chat.
Oh, she wrote that. Okay. Yeah, I can't see the chat. I'm very sorry.
No, that's all good. I just wanted to let you know.
Yep. Okay. Maybe I can keep the chat box right here. Ashley, is it better for you? Maybe she went to go get headsets or something. Okay, but the bottom line is when you're looking at this table right now, it is very hard to actually make sense of anything, right? Because there's too many data points. Whenever you have a table where the number of rows that you have spans 3 columns, I mean, if you look at that, that's a lot. So a much better way to organize this data is to group it even more. Because right now we grouped it by the number of interactions, but I think we can make ranges and that would be more meaningful. And it would look something like this. So again, it's the same data, but now I've clumped it. So I've said 0 to 4 interactions in a week. There's actually 12. You know, the frequency is 12 versus 5 to 9. Now, something to be very mindful of when you're doing a table like this is that you need to pick an even number for your grouping. So you can't do 0 to 10, 10 to 12, 13 to 15, 15 to 60, right? Like that, those are unequal groups. That's not going to be as meaningful. And in fact, oftentimes in advertising or whenever they're trying to skew data, that's one way you can do it, right? Say 10 and less and 11 to 50. Oh, 11 to 50 is much higher. Well, by virtue of the fact that you have more cases, of course it's going to be higher. So in order to be an ethical statistician and social scientist, you want to make sure that all of your groupings are the same. So now looking at this, what do we see? What comes through?
That anything above 30 is less frequent than anything below 30.
100%, yeah, absolutely. So if you have 30 or more interactions in a week, you're kind of an outlier, right? That's not where the bulk of people are lying. They're really up above at 30 or less per week. But a quick way that we could actually verify that is also by doing a cumulative percentage, and we'll look at that in just a minute. So looking through here, this is, by the way, this is the same table, right? Okay, we've just divided it again. Oh no, this is not the same table at all. Sorry, totally different table. You're like, what? No, the cumulative percentage, the way we could do that here is that we could add it up. I'm gonna deal with that exact same table in a couple slides. We'll revisit it. So stay tuned. I've just dangled the most exciting table ever. All right, again, this is using the GSS subsample, so the General Social Survey. It's grouped frequency distribution of the variable age. So again, people answered the survey and we asked them, how old are you? And this is how it broke down. So if I look at the age groups, 20 to 29, 30 to 39, again, we're spanning a 9-year age frame there as we go through each group. And you can see the frequency for each and then the percentage for each. So that then you can take a peek and say, actually, you know, if I look at ages 49 and under, that's like 65% of my data comes. So I just added 17.5 plus 17.5 plus 30, quick math, 65% is aged 49 and younger, which is that meaningful? Maybe, but when you're presenting your data to someone, you can present this, which gives you far more granular data, or you could say in broader category, like 65% were in the workforce, so you can even add more. If we're gonna say that people under the age of 70, you know, are in the workforce, let's say you add another, what, 15% to that. So 80% of my sample were in the workforce, or 20% were retired. There's different ways that you can kind of, again, describe the data. You're not manipulating any numbers, you're just finding ways to describe your data in the most meaningful way.
Sorry, could I ask a quick question on the last slide?
Of course.
So the frequency numbers in that category? What does that represent again?
So when you see like 20 to 29 is 7, is that what you mean?
Yeah.
Yeah. So that means you gave a survey to 40 different people, and
Okay.
7 of them acknowledged that they were between the ages of 20 and 29.
Oh, okay.
So that's saying you put out 40 surveys, right? And it was a general social survey about how many kids they had. You know, it's a very broad survey. And out of those 40, 7 of them were between the ages of 20 and 29. And like 2 of them were between the ages of 80 and 89. That's what that's saying.
Okay. Thank
that
you.
help?
Yes.
Okay. Is it not super clear from that? Is that?
Sorry, I just thought I heard that we were talking about like other variables too, and so the frequency got a little muddled for me.
Okay, perfect. I just want to make sure that I'm clear and I'm also like speaking clearly. So thank you for keeping me on it. Okay. All right, so stated limit versus real limits. So this is something that's going to be important too. When we deal with data such as age, you know, unless you're dealing with a 6-month-old, you know, there's those parents, I'm sure you guys have met them. I was one of them. People are like, oh, how old's your baby? I'm like, they're 31 weeks old. Like, you got to do math. Like, what is, just give me months, right? And then after a while, saying months is not helpful. Oh, how old is your toddler? Oh, he's 28 months old. Okay, what is that? The math, 24, right? 2 year, just say 2.5, right? But once you get older in life, unless you're, you know, my 8-year-old who loves to be like, well, I am 8 3/4 because he's my very accurate child. Most often with age, we're dealing with round numbers, right? So when you say the age category is 20 to 29, what are you really including in that? So the idea of real limits versus stated limits becomes important, especially with continuous variables, meaning those are variables that can take on any whole number, right? So how tall are you? This would be a good example of that. Well, if I'm going to say it in inches, that's one way, but if, again, in centimeters, then it gets incrementally small as to how, you know, different one is from the other. So having like a real limit from a stated limit is going to be important. So your stated limit is when you take a look at your category within that data, so 20 to 29. The real limit, though, has a buffer on either end. So it's telling us I'm actually going to be really measuring 19.5 to 20.5. Anything within that, that's really my real limit, and that's where people are going to get categorized. This is only going to be important if you've got really funky data that you have to try to organize and sort. Because again, you want your midpoint. Anyway, I feel like I can get in the reads with that, and we don't need to get confusing. Just know that depending on the category, it may be a little bit outside of the stated limit. Your real limits will be noted. So just tuck that in your back pocket. And when I'm like, remember the real limits? You'll be like, oh yeah, she said something about that. We'll deal with that later on. Okay. Cumulative frequency, I've already started talking about this. And again, that's helpful when you're trying to categorize data just in a more broad fashion. So a cumulative frequency distribution is a distribution that shows the frequency at or below each category of the variable. Now notice my hand went up when I said below, and that's because the lower values in the table are higher up in it, right? So for instance, if I look here, you guys can't see. You can see can you see my cursor?
Yep.
Okay. So these are the lower categories. But again, if I'm trying to figure out, right, what is the specific cumulative frequency, I am adding up these variables right here. So if I'm trying to figure out here, what is the total cumulative frequency for people ages 59 and under, I am adding up all of these numbers here. Okay, so 7 plus 7 plus 12 plus 3, which gives me 29. Okay, so then in this particular example, that's what I'm looking at in terms of the cumulative frequency, the total number of times it's happened. So 29. Now this is not percentage, so we need to separate that. Cumulative frequency is just adding up the number of times it happens. So this is 29, but remember, what's our total?
40?
40, right? Okay, so right away, if I know that this is 29, 40 is my total, once I do actually look at percentages, this makes a lot more sense too. So I've got my frequency here, and here's the percentage, right? 7 out of 40, 7 out of 40, so these two are 17.5, 12 out of 40 is 30, right? And then I could do cumulative percentage, which is exactly the same thing I just did with cumulative frequency, except now I'm looking at percentages, which frankly is a little bit more useful. So here, if I'm looking at 59 and under, it'd be 72.5%. Now maybe you're pausing and you're like, how in the heck did she get there? So let's back it up again. So if I know that there's 7 that fall between the age group of 20 and 29, 7 divided by 40 times 100 gives me 17.5. That's the percentage that fall in that group. Now it just so happens that 30 and 39 is the same number, so 17.5. Now if I want to know what is the total percentage of my sample that is age 39 and younger, I have to add up these two, which gives me 35%. Okay, is everyone tracking on that? How we get a cumulative percentage?
Yep.
Okay, any questions? The best thing to do when you guys are trying to figure those out, and you will be asked to do a frequency table with a percentage and a cumulative percentage. So know how to do this. The easiest way is make sure that you draw out exactly each row and column so you have them all mapped out, like literally on your piece of paper with a pen, or get fancy and use Excel. Those are all drawn up already. But then you can just do the percentages for each and then add up the cumulative percentage, okay? So again, this is not complex math. It's just about organizing your data. The biggest mistake I see with students is that you try to do it too quickly. And so I will give you a data set, which will have a bunch of jumbled up numbers, and then you have to actually do a frequency, and then somehow you'll forget a number, right? You'll just totally skip one. So then all your numbers are kind of off moving forward. So little hint, when you're creating a frequency table and you have a data set at the top, as you account for it, mark it off, right? Again, I'm big on paper and pencil, but it just makes it so you don't forget anything, and then add it up in your frequency table. Okay, questions? Okay, all right, let's keep trucking. All right, what is a rate? So again, this is a word that you'll hear often when people are sharing information and sharing data. What is the rate? What is so again, marriage rate, divorce rate is actually more often what we ask about. Poverty rate, what is the birth rate? Any of those things, let's see. Oh, good. So what is a rate? Why do we care about that? So it's the number that's obtained by dividing the number of actual occurrences in a given time period by the number of possible occurrences. So it's taking a frequency in a sample, dividing it by population so that you have an entire picture. So birth rate, so just side note, with that, there's a little bit of extrapolation that goes through with it as well. So it's saying this is what we see, right? This is the frequency that happens in the sample. Now for the entire population, this is what it would look like. Can you guys think of other rates? So I put here birth rate, unemployment rate, marriage or divorce rate, poverty rate. Anything else come to mind?
Graduation rate.
Graduation rate, great one. I think somehow crime rate, that would be another one that you could calculate within a specific geographic region. Anything else?
Think of a death rate for like COVID and stuff.
Oh, that's a great one. Now, I didn't get to see who said that. Was that Daniel?
It was Daniel, yeah.
You guys always bringing back COVID. That's just anxious. I'm trying not to step in it and say anything non-PC, but that's an excellent one. Yeah. So we can look at all aspects of COVID with rates, right? So death rate, folks would be really interested in recovery rate, right? What else would we want to know about COVID and rates? Transmission rate, probably be a big one we'd want to know. Anything else? That kind of exhausted. Okay, moving right along then. Okay. So a little bit more about rates. So if I was trying to figure out what is the poverty rate in 2014, again, that's some of the census data that we have back from 2014. So we can take the number of men and women that are in actual poverty in 2014, that's the actual occurrence, divided by the total population in 2014. That's the total possible occurrence, right? Again, when you do a census, that is a population measure. You're looking at the entire population of a given country, region, whatever. So again, even for Aquinas, if I was trying to figure out poverty rate, seems like it might be 100 students. I remember being a student being real poor. But for the population of Aquinas, maybe I'd be interested in seeing what is the rate of student athletes. Let's say that's what I want to know. I would count every single student athlete out of the total number, the population of Aquinas students. So that would be doing a rate that way. So the poverty rate in the US in 2014, so again, the number of people in poverty divided by the population. So that gives me a very high number, right? 46,657,000 divided by 315 million, right? Which was the total population in 2014, which gives me a poverty rate of 15%. Now I can refine it even smaller. I can say, what is the poverty rate for people 18 and younger? So now my total population is no longer 315 million. Now it's going to be 73 million. Those are the number of people. Again, if you're looking at that frequency table, I'm saying 18 and up higher in the chart, right? 18 and younger. So I've got 73 million that I'm comparing against, and there's 15,540,000 that qualified or that fell in that being in poverty. And so that gives me a 21% poverty rate for those 18 and younger. So it's quite frequent that rates are often expressed per 1,000 or 100,000, so that it eliminates the decimal points and it's just easier to interpret. It's just data that's more easily digestible. So that's when you'll hear it's 150 and 1,000 people, or there was something that came out recently, actually about COVID too, transmission rate on planes. I don't know if you guys read that article. It was like 1 in 7,000. So people talk about that in those terms because it's a little bit easier to picture and imagine, right? So you know yourself, I'm 1 in 1,000 or 7,000, I can kind of picture that. But if I wrote the chance of transitions at 0.0007, people might go, oh, that's real, and that's nothing, or whatever. It just is harder maybe to grasp than saying 1 in X number of thousand or 1 in a million. You hear that too, like what's the chance of you getting struck by lightning, right? Or getting eaten by an alligator, or we just talked about that. Didn't we talk about that, like shark attacks, death by shark versus, that might have been in my research class now that I think about it. But again, the way you describe rates, it makes it a little bit easier if it's in that way. So again, poverty rate, and again, divorce rate would fall into that. They're considered crude rate, and that's because they're based on an entire population, but only at a given time, right? You take the census once, and then you wait X number of years before you take it again. So it's not ever evolving, ever accurate. It's just the population based on a given period of time. So because of that, it's a crude rate. Now, the population of Aquinas, that'd be far more specific because we know how many students are registered every single semester, right? For a census, for an entire population, it's much harder to negotiate. So we call it crude rate. Okay, so how do we read tables? We just had an example of that at the start of class. We want to know, what is the source? Where are they getting the data from? How many variables are presented, and what are the names of the variables? All things that were very much lacking in the example I showed you. And what's represented in that first column of numbers, and what about the second column? And are they comparing the same data, right? Is it on the same scale? Because that matters too. Okay, so here we're looking at the percentage distribution of access to public benefits amongst Mexican immigrants and US-born unmarried mothers. Take a deep breath, that was a long title. First off, you don't do that. Have a much simpler title when you come up with your things, with your research. But here's the variable. So it breaks down into two. So first we have Mexican born, then we have US born, but of different immigrant population. So Mexican American, Black non-Hispanic, white non-Hispanic, and the total US born population. Okay, and then we're looking specifically at prenatal care in the first 3 months of pregnancy. Okay, lots of data that's being displayed here. I've got different types of health insurance, whether they're getting food stamps, rent assistance, if they're part of a WIC program. And then you see through here, these are presumably percentages. Yeah, percentage distribution. So you go through and you can see how much they're getting. Now, do you guys have questions about this table? I have a lot of questions. So just based on what we talked about, like A, what's the source? Where are they getting this information from, right? Is it based on one period of time? What year is it, right? Who responded to the survey? Was it government gathered or was it self-report? Right? I would have a lot. What variables are being presented here? We have a lot of variables, right?
What health insurance they have?
Yep, that's one variable. Whether they have,
What is TANF receipt? What's that stand for?
it's temporary assistance for needy families.
Oh.
Yeah. And then WIC is women and infant and children. It's additional help that they can receive. So again, we've got all of these variables, but even at the top, they're classified in different groups. So what's represented by the first column versus the second column? So here, this is Mexican immigrants, right? So they were born in Mexico, but this is US born, but are they of Mexican American descent? I would want to know, how did you define that, right? How did you figure that out? And then this is always a big group, like Black non-Hispanic, white non-Hispanic, and then the total population. So presumably with this table, they're making inferences as to the total US born population, this column, comparing it to these different groups. This is, I think, what they're trying to say is our control group, and they compared it to everything else. And then this, I think, got all slanted over. This may have been when I copied the table over.
Okay, I was just about to ask why Mexican immigrants didn't have any prenatal care in the first.
Care, that's problematic. Yeah, I'm thinking the 78.1 should be right up here. Yeah. Okay. So, but you see, here's a table with tons of data, and I think as much data as they're giving it, I have just as many questions. It is too full. I would divide this into multiple tables. That would be much easier to grasp, right? And if you're going to make a comparison, which I think with a table like this they're trying to do, between some sort of control group, or if your idea is if US born versus Mexican born, if you just divide it by these two groups, that might make more sense. And then have a separate table that says US born, but what racial group do you identify with? Then have a table for that. You know, there'd be ways to simplify the data a little bit. That brings in more information and fewer questions. Okay, so this is another way to do the exact same thing. So this was the same data, right? And then it's looking specifically at what is statistically significant. You guys have likely seen that in research when you've looked at papers. So first off, already we have a source. So that is the, oh, maybe I need to be over here. Do you guys see my cursor? So we have the source of where they got this information, right? This is reported in Padilla et al. 2006. We then have a little bit of a note here as to how they're describing this with more data. And then the asterisks denote what is statistically significant. There's still some question here because they're statistically significant from what? There needs to be more, depiction of that. So looking at just a table like that is hard to read. And here's why we have graphs, because graphs can show us the same information, but visually, so the take-home message is a little easier to digest. So one of those examples would be to do a pie chart. Now, when have you guys seen pie charts? What comes up as?
All the time in textbooks.
All the time in textbooks, that's true. Anywhere else?
I don't want to go back to the Verizon commercial, but
Yeah,
yeah.
that's another good one. Yeah.
Ooh, billboards.
Billboards, that's huge, right? Because a billboard, right? What is the goal of a billboard? Like, would we ever have this on a billboard?
No.
No, people be like, what is happening over there, right? There's no time, right? I'm not understanding what I'm looking at. But a pie chart can quickly show you, usually with bright colors, right? Here's the huge section in blue. Oh, what does that say? And that says, you know, whatever the message the advertisement is supposed to be getting. It's meant to be easy, concise, clear to understand, and like anyone else seeing this would be following that same path. So that's why for advertisement, that's huge. Now, when you're trying to utilize a pie chart to display your data and statistics, you need to be mindful of something else, which is that the total needs to add up to 100, right? So you can't do something that has more than 100%. That just will not work for a pie chart. I mean, again, the whole reason behind a pie chart is, oh, if I cut this big piece, that's how we describe fractions to kids in school when we first divided. You have a pie and you need to share with 8 of your friends. How would you cut it? And you go, oh, and each piece represents 1/8, right? It would make no sense that each piece represents 3/8. And then you have 8 pieces. That's more than a whole, right? That does not add up. They'd be stacked pieces of pie. Kids would be confused for days. So the pie chart needs to add up to 100% of all the frequencies. So whatever the total is. So oftentimes it'll be hours per day, right? That's another quick way that people will have. So how many hours per day do you do the following activities, or do teenagers engage? So then you'll have sleep will be a big part. Study, social activities, sports, eating, social media, right? Like you can see how then you would make up an entire day based on hours. Something else that oftentimes like a racial distribution, right? So within this country or within this university or this institution, the whole population, that's the whole pie. And now let's divide it up by our demographic variable, whatever that is. You'll see it often with just gender, with religious group. So it's a really good way to show in a visual representation some of those demographic variables we've been talking about. Okay, so here's an example of one. This is the 5-year estimates of the US population that'll be 65 years and over, divided up by race. So again, we've got the entire population. That's our whole pie. It is based on the US Census Bureau, as you can see here, and that was gathered for the 2014 group. And then you can see here by shades of color, the different groups. Now, anything you'd want to improve on based on this graph looking at it?
I think that there should be like definitely red or yellow, because I'm looking at, there's like light blue, lighter blue, kind of blue. And I'm like, is that, what is that in there?
100%. I totally agree with you, Elizabeth. Again, the whole point of a pie chart is to make things visually clear. And looking at that, that's not super clear. You're seeing different gradients, but I'm having to go back to the legend at the bottom and go, wait, what? Which one is which, right? Now, is anybody colorblind in this class? Because I feel like that might be your worst nightmare. You might go, and 100%. It's all the same, right? So you want to do some variety in terms of color. Absolutely. Okay, here's another way to depict it. So this, by the way, same information. Which one is easier to see?
The second one?
Okay, why is it easier?
They grouped more things together than
They
in the
sure
first
did.
one.
Yep. So they realize here we have several categories here that are less than 1%. So why don't we clump those together? Again, whenever we clump together, what do we lose?
Being specific.
We lose specificity. That's exactly right. But we gain from it greater clarity, because now we can go, oh, okay, yeah. Now, if I'm looking at this legend, maybe I'm thinking, oh, okay, what is this other category that's 5.9? Do I care that I have anything else other? That's a very wide vague category, and that I have almost 6% that's other. Well, maybe I do. And then from that 6%, what I could do is I could create a new pie chart that would break down that 6% to these subcategories, but they would seem a lot larger because my whole would be that 6%. So you could have a pie chart like that, and then another one that explain away just the 5.9, right? You could certainly do that. In fact, I think that would be a better way to go than this nonsense when you're like, what am I looking at here? I mean, there's even this category, the 0.1% is the line.
I don't even know what that's trying to like point out.
I think it's 2 or more races combined. No, that might be
Could
one.
it be the Hawaiians?
Hawaiian, yeah. Gang, again, could this be clearer that it's not clear? Yeah. All right, bar graphs. We talked about this a little bit earlier. A bar graph shows the differences in the frequencies, or it could be also percentages. You could do one or the other, among categories of a nominal or ordinal variable. You are not going to do it for a this is big asterisks, okay? Make a note. You use bar graphs for nominal or ordinal variables. If you have a continuous variable, you will use a histogram. So let's keep those two clear. Here's the way that it's different. A bar graph will have the columns separate of each other. So if you look here, I'm going to scoot to the next one here. You see how the columns are not touching one another? It's because they're really distinct categories. They in fact have nothing to do with one another, right? Like where married ends is not where widowed begins, right? That would be a very sad concept. I guess it does lifelong. Anyway, I shouldn't go down that rabbit hole. But they're a nominal variable, right? This is not ordinal. It's not like they go up in sequence one from the other. It's not strongly agree, neutral. Do you know what I mean? This is a nominal variable. So this is the marital status specifically of US elderly. You can see 54% are married, 28.6 are widowed, 11.2 are divorced, 1.2 are separated, and 4.2% never married. So this is how your data in a bar graph can show this information. Again, could we have used a pie chart for that?
Yeah.
Yes, very much so. You could have a pie chart that represents 100% of the elderly population in the US in 2010, and then each segment would have been the different groups. You could have said that's married, that's widowed, that's divorced. Definitely could have done that. It might have not been quite as easy, excuse me.
Bless you.
Thank you. Thank you. To see as a bar graph, but you could have done that as well. Okay, anything else? Yeah, I said all of that, so we're good to go. Now you can have a bar graph that goes this way, right? Or a bar graph, so this way would be vertical using my big PhD words, and this way would be horizontal, okay? So this is the marital status of US elderly, but it's divided by gender. So already from here to here, we have more information because we've now split up between gender for each of those categories. So whereas here, this is the entire whole, this 54.2% bar includes both male and females. Now I've divided it up. And what do I see? Men are right about the 70%, let's say, I'm doing an estimation here, and women are right around the 42% that are in the married category. By the way, any thought as to why that would be split this way?
I mean, men die, or because the widowed is so much higher, so it shows that the men are, well, better, worse term. The men die, and then the women aren't married anymore.
Exactly. Yeah, I just love that. The men die. That's just what happens. And that's true, right? So it looks at mortality rate between men and women, right? And men are more likely to die earlier, which is why if they're reporting at this age, 65 or older, that they're still married, there's fewer women that are still married, presumably because their spouses died. And this is really mirrored right here, that there are fewer men that are widowed than there are women. So those two really kind of clump together and make sense. So just by subdividing by gender, I just got a ton more information. Now, maybe looking at this, I created a hypothesis of like, okay, I'm just going to go off the deep end here, but you're thinking out loud. What, 4.2% of the elderly 65 years or older never married? I bet you these are all cat ladies and they just never found their spouses. And it shows 4.2% because whatever single men were out there, they've already died off. Create this hypothesis. And then you dive deeper and then what do you find?
That it's about even.
It's about even, right? So my hypothesis would be refuted right away by splitting it by gender. So again, there's value in doing something like this because it gives us more information. There's more data that's represented. Sorry about that. Somebody's sorry about that. The little things I learned by teaching in my house. I need to disconnect my Alexa here. Oh, I just said her name. I hope she okay. This is the life we're living in. Okay, statistical maps. The cell phone example that we used earlier, how often do we see that for cell phone ads? Were you saying something, Mary Pat?
Oh no, I just switched over from my phone to my laptop, so I think that it was like unmuted real quick.
No
But I did.
problem. No, it's okay. So how often do we see this though with cell phone ads?
On every
Almost
commercial.
every single one.
All the time, right? Like you'll see coverage by Verizon, and it'll be like different colors, right? There's really cool maps out there of, oh, this was on Facebook a few years back, like how people say pop or soda. Did you guys ever see those?
Ah, yeah, I do. Like in
Yeah.
the Midwest, and like it kind of breaks it up into like subcategories of where people say it.
Exactly. So it shows in the country the percentage of people that say soda versus pop. And then some parts of the South just call it Coke. Yeah. So I didn't know that. Or it'll say there's other things. So I'm from Canada. I showed that earlier. And it'll have the Canadian map with the provinces and then different. So a toque, right? Like the beanie hat that you wear in the winter. So it showed like the percentage of people who called it a toque or a tuck, I think people anglicize it, versus a beanie and divide it up. So the statistical maps can be really interesting, especially when looking at language. Now you can take it this way, which is this is looking at unemployment rates by county. And then you can highlight, again, this is a better map in terms of color as to what is the unemployment rate, at 1.9% or lower, all the way to 10 or more. So you can really show dramatic changes within different parts of the country, and it's very visually accurate. Now, if I took the same information and had a bar graph showing different states and unemployment rate, it might look a little bit, jumbled, but then I would have 50 bars, right? That's it's cumbersome. It's a little bit of a nuisance to read that. A statistical map, I don't need to have a bar that said North Dakota. I can just, I don't know, do we know where North Dakota is? My sister lives there, that's why I know, but I picked an esoteric state. But you could just look at the map and then say like, oh, what am I noticing? Where is the lowest rate of unemployment? Or what trends can I come up with looking at this map? What do you guys think?
The unemployment rate in the Midwest is higher than what would you call the middle of America? The mid?
Right, it's like, what is that? It's like central?
Yes.
Yeah.
Midwest America has a higher unemployment rate than Central America.
Right, or even more broadly, you could say the coasts experience a higher unemployment rate than, what are these states right here? Like, no joke now, I'm not messing. Is that North Dakota, South Dakota, Nebraska?
I think
Yeah, Kansas.
Kansas, Nebraska. What's this one? That's not Kentucky.
Oklahoma.
Oklahoma. You guys, this is bad, but I just will hold on to my excuse that I'm Canadian. Bring on the provinces. I will identify those all day long. But okay, so yeah, going back to Kyle's question, what would you guys refer to this section? The prairie?
Great.
The what?
I would say the Great Plains.
Great Plains. Ada, you're on it. What is your major geography? Make me feel better and tell me yes.
No.
Okay. All right. So this is an example, again, using a statistical map gives us instant information. I mean, we have to kind of, do some deciphering, obviously, with the different colors, but it can be really dramatic to just look at it. What's another thing that we always see with the statistical map? It's already written as an example, but voting patterns, right? Election night, those will be like clustered different colors, and then each county will be shaded. Actually, that was an assignment for my daughter who was in 4th grade, the last election, where she had to, they're like, stay up as the, votes are counted and color. I'm like, what? She's not staying up till midnight as counties are being decided. But yeah, like coloring each different section to see how states are called. So again, unemployment rate's pretty huge, voting pattern, population distribution, that's another big one where you can cluster in larger group, which look at population density, and then crime rate is another big one. Okay, we are gonna stop here and we will tackle the histogram next week. So why don't we take a break right now? Let's take a 20-minute break, come back in at 4, and we are gonna go over the lab and how to do it and get it all together. If you struggle to submit your quiz, please let me know, email me, text me during the break, and we'll figure it out. Okay?
Perfect.
See you all at 4.
Should we have Excel up, or can we just watch this time what you're gonna do?
I want both. So if you could have Excel or numbers or whatever you're gonna use up on your computer as like a side icon, I'm gonna share my screen and show you how to do it. But then I want you guys to be able to do it at the same time and replicate the number I got before I let you go and do the last analysis on your own.
Okay, thank you.
No problem. All right, see you guys at 4.
Okay.